Ladies and gentlemen, thank you for standing by. Welcome to the Partnership of Federal Highway and Pavement Preservation and Recycling Alliance webinar. At this time, all participants are in a listen-only mode. Later, we will conduct a question and answer session, and instructions will be given at that time. We will try to answer your chat questions as we go, but if there are many, we may continue with the presentation and answer them at the end. If you should require assistance during the call, please press star then 0. I would now like to turn the conference over to your host, Jason Dietz. Please go ahead, sir.
Thank you, Kari. Welcome, everyone. I appreciate everybody's time, able to sit in this webinar today. This is a series of webinars from Federal Highway and PPRA that we are currently doing once per month, and we're delighted to have you participate in today's webinar. Our guest speaker today is Chuck Ingram. He's a sales manager for Slurry Pavers Incorporated. He has been in the pavement industry for 43 years. He began his work as a Slurry Pavers Incorporated in March 1977. He's been actively involved with the International Slurry Surfacing Association for over 20 years. He currently serves as a vice president on the ISA Board of Directors and chair of Quality, Education, and Training Committee. In addition, he is active with FHWA, Virginia Asphalt Association, and the Virginia Transportation Construction Alliance and County Engineers. He is married, he lives in Lynchburg, Virginia, and he has 4 daughters and 4 grandchildren. I asked him for a hobby, and he responded back saying, the golf courses are open to Virginia, but can't wait for the restrictions to be relaxed so he can spend the time with his 4 grandchildren. So with that, I'd like to introduce our speaker for today, Chuck Ingram. Chuck.
All right. Well, thank you, Jason. I do appreciate it. As Jason said, I'm Chuck Ingram. I do work with a contractor here on the East Coast, doing most of our work on the Mid-Atlantic region of the country. Today we're going to talk about the introduction to slurry surfacing systems and where they can be best used and put to work in your networks. We're going to start off talking about a history of how these treatments came to be, and being that this is the first ISSA installment in this webinar series, I felt it'd be worth spending a few minutes to talk about just why we do need pavement preservation in our program. When we get going, we're going to talk about and define each discipline represented by ISSA, which is a slurry seal, the microsurfacing, and a newly introduced guideline specification for a polymer modified slurry seal. And they're represented by guidelines A105, A143, and A115. We'll talk about, as we go along, the benefits of these treatments. Then we're going to get into just what is the right road that we're looking for. What kind of road conditions are suitable for applications of thin maintenance applications like this. And we're going to try to identify some qualified candidates. And as we wrap up, we're going to talk about how possibly, we're all in situations sometimes where deterioration gets a little bit ahead of us. We're going to talk about different uses and recommendations for some of these treatments and how we can combine one or more of the ISSA represented disciplines to fix the particular defect in the pavement. These thin treatments were first developed in the 30s in Europe as a mixture of fine aggregate, asphalt emulsion, and water that they referred to as a micro-asphalt concrete was their first attempts to apply thin restorative treatments to roadways just to try to prolong their life. Experimentation continued with these ideas up until the 60s when it became evident that these were some viable treatments that could be put to work in the networks. We had by that time better access to creating better emulsifiers for the emulsions that we were using, and the equipment had started taking on some pretty significant advancements as well. In the 70s in France, a company called Spray Group developed a polymer modified version of these early slurry seals and their proprietary name for their product was seal gum, and they had some good successes with it. And in the 1980s, a German outfit, Roche Corporation, was challenged by the German Ministry of Transport to come up with a thin treatment that could arrest and correct some early deteriorations on their autobahns, particularly because of some very expensive pavement markings that had been placed. They didn't want to sacrifice the life that was still left in those pavement markings, and so there was a thin treatment placed on the autobahns to straddle those pavements and keep them in place. Showed a lot of promise, and by the early 80s, Volumac was introduced into the United States market in the Midwest and then migrated across the country. Procurement practices would preclude proprietary materials from being specified, so industry came up with a generic term of microsurfacing to describe what these treatments were, and since it's just taken off, and these slurry systems are now extensively used worldwide. Let's begin by defining pavement preservation. The FHWA Pavement Preservation Expert Task Force describes pavement preservation as a program employing a network-level long-term strategy that enhances pavement performance by using an integrated, cost-effective set of practices that extend pavement life, improve safety, and meet motorist expectations. Well, then we'll go and take an excerpt out of an FHWA action memo that says that pavement preservation involves a paradigm shift away from the worst first type of philosophy and moving on to a more proactive optimum timing approach to placing these types of treatments on roadways. In other words, not waiting for the roads to go completely out of shape before we do anything to them. And at that point, they're obviously too far gone for these thin preventive maintenance treatments anyway. But one of my favorites, I tell you, back in the mid-'70s when I first got my start in this industry here in Virginia, got to know one of the maintenance engineers who said, you know, as we were promoting and placing a lot of slurry seals at the time, he says that these preventive maintenance treatments are really something that you need to put on a road a year before you really need something else. And, you know, just think about it. That's really just sort of puts it all in perspective. How many calls do you get from some of your constituents saying that, you know, what are you doing something to my road by placing this stuff on it that really didn't need anything? The road around the corner is in worse shape. So, but that should be a pat on your back for being proactive and treating roads before they really needed something more aggressive. An effective pavement preservation program is one that's going to address good pavements ahead of the time when those distresses start setting in. And we'll just arbitrarily say that sometime about 4 to 7 years after that pavement was installed is about the time that some of these distresses might start showing up. And it might be a good time to start planning and applying some of these treatments, because if they're applied at the right time, you're going to restore that pavement to almost new condition. It'll never get back up to as-built condition, but you'll certainly improve the surface conditions of it. And it's been proven that the cumulative effect of these treatments are going to postpone rehab and costly reconstruction activities down the road. And in the meantime, be less expensive in the long run. And due to the fact that the application processes with these slurry surfacing systems is relatively quick application time, it's going to be much less disruptive to traffic. Now, I plugged in this little picture on this slide. It's one that a county agency customer of mine calls his poster child road. When he is selling every year in his budget cycle to county council, the line item for pavement preservation, anyone that has any question about what he's talking about, he just sends them out there to review this road with the story behind it. This particular road was paved originally 17 years ago. In year 7, he applied a microsurfacing treatment to this road. And then at the end of year 6, somewhere between year 6 and 7 of the microsurfacing application, reviewed the road and found that it was still in good enough shape and placed another microsurfacing treatment on it. So the road, as you see right here, is technically 17 years old and is between 4 and 5 years into the second application of the microsurfacing. There's 3 primary uses for pavement preservation, and they're all applicable using the ISSA disciplines, either slurry seal, microsurfacing, or the polymer modified slurry that we'll talk about in a little while. But they're dependent on the timing of the application. The best use of your dollars is going to be in the first category with preventive maintenance, when we're going to try to catch those surface distresses in good pavements before they really take hold. And realistically, though, in a lot of cases, we're going to be moving down that pavement preservation or pavement condition curve, the distresses may have already started to set in to a small degree. And once you're starting to have distresses that need to be fixed, then we're technically into a corrective maintenance mode. And how many of you out there, and Jason, this might be a good time to cue that next question, we find a road that we just know that we've ignored too long. It's not really at the time or at the time in our budget that we can afford to go and do anything real serious to the road. So we need something to buy time on some of these roadways. It's not the recommended time to be using a slurry seal or a microsurfacing on a roadway, but inevitably we're all going to get in that situation where we just have to simply buy some time for this road and get it over the hump. And this one right here, and I think if I'm looking at a thing right in front of the chart, Jason, I'm not sure if we can move it. There we go. Thank you. We've all seen a pavement condition index curve at one way or another. And what I want to do is just draw your attention to the heavy red line. It's just theoretically, we're going to say that that is the pavement condition line and how the pavement conditions will be tracked over time. For argument's sake, in this model, we'll say that this asphalt pavement is designed to make it to 13 or 14 years before some serious investment is going to be needed to get it back up into that much better serviceable condition, if not replaced. And we go back up the curve a little bit to about year 9 and 10. Okay, that's about 75% into the expected life of this asphalt pavement after it's been placed. During that first 9 years or so, you're going to lose about 40% of the quality that's been built into that pavement. So somewhere in the middle of that curve, we're going to argue that up and around year 4, 5, 6, or 7, an application of a slurry seal or a microsurfacing, if I can get this arrow to work. I'm not getting it to click on, Jason. But anyway, the halfway up in that curve is, there we go, where we can apply a slurry seal treatment to it. Now, see that this condition curve is bumped up a bit, but it's not to the as-new, as-built condition. But more importantly, what we're seeing on this curve is that it is flattening this curve and extending the serviceable life of the pavement out another 5 or 6 years. And then at that point, it's not unreasonable to expect that we'll be able to apply a second and subsequent application of the same material to it for a lot less money than if we wait down the line. We're still keeping this pavement in and above the good condition, even as we extend it out. A graphic example of some cost savings, if you're spending, relative $2 each time versus going further down the curve here. Now, if you get further down this curve into the last 2 or 3 years of that expected life of the pavement, you can see that we're losing just as much time here as we did in the first 9 years of pavement. We're losing 40% of the quality in this next 2 or 3 years. You're down the curve, you're between poor and fair, but this is that road where you just got to do something to buy a little bit of time. Okay, so yes, you can apply your microsurfacing application here, and you're going to immediately improve and spike the condition of it back up into the fair category. But what's going to happen by virtue of waiting this far down the curve to apply it is you're going to mirror that deterioration curve pretty quickly. And what that translates to is about doubling the cost on a life cycle costing cycle for you. So the lesson learned is just more timely applications up here on the top of the curve to save the money. A graphic example of this one, and I had the opportunity to meet the Public Works Director in Fairfield, Connecticut. There's two side-by-side towns in Connecticut that share responsibilities for Park Avenue. The double yellow separates one town from another. In 2004, they pulled their finances and did a 2-inch mill and fill. 6 years later, the Public Works Department in Fairfield, Connecticut, familiar with pavement preservation, decided to do a little bit of crack sealing and apply one coat of microsurfacing to the pavement. Now that's 6 years from when this picture was taken. So you've got 6 years life of microsurfacing, extending the life of the road that was originally built in 2004. And meanwhile, the neighboring town has chosen to do nothing for these 16 years other than do a little bit of pothole patching. So, you know, you tell me what side of the street you want to live on to get bang for your buck in terms of tax revenues. In another example of a champion customer or a champion agency that I'll call it, I'm a little more familiar with this one. It was a county agency with a $12 million capital budget set aside for their resurfacing program. Now, we're all going to have those roads that need a little bit more than just either maintenance or even a mill and fill. So a small portion, or 16% of his budget this particular year, was spent on his reconstruction and rehab. But as you can imagine, he only touched a small portion of the roads to be touched that year. That's 6%. The mill and fill portion of his program that year, the resurfacing program, eats up a significant amount of his budget, which is nearly 60%. And he is touching about 30% of the planned lane miles to be touched that year with his $12 million. Then he gets into the category that they refer to as surface treatments and patching, where they will do some surface patching, taking care of some localized bad spots. They have an aggressive slurry seal, microsurfacing, and chip seal program, of which they're determining to spend about 18% a year of their total budget. But the big key that I want to point out here is that they are taking that philosophy, and they're touching nearly 60% of the year of the road that they're going to pave that year by employing a pavement preservation program. Okay, so what we're going to talk a little bit about right now are the ISSA guideline specifications. We're going to detail the three disciplines that we're going to talk about. Now, these performance guidelines are just that. They're meant for you to use to help build your own specifications from. These are no more than guidelines. They got some good information in them. But you can go to www.slurry.org, and you're going to go to the Education and Resources tab, and you'll be able to have access to all three of these guideline specifications. They're downloadable and they're printable. It's a good source of information for those of you that may be just trying to figure out how to get into this type of activity. And the A105 is going to represent the emulsified asphalt slurry steel. The A143 represents the microsurfacing treatment. And the newly released A115 guideline specification covers the polymer modified emulsified asphalt slurry seal. And we're going to get into describing the differences right now. But by and large, a slurry surfacing mix can briefly be described as a mixture of a continuously graded fine aggregate, add some mineral filler, emulsified asphalt and additional water, proportioned properly and mixed and spread as a surface treatment on a road that is currently in honestly pretty good shape. We've got to start with a road that's in good sound condition, no structural defects necessarily, because as I say to a lot of the people we work with, these slurry surfacing treatments are really no better than what you put them on top of. But we'll find a way to get those roads restored to good enough condition here shortly. But when these mixes are applied, the cured slurry material is going to have a homogeneous appearance. And I really want to point this out here. I can't get the click for the fill. These materials are not designed to heal cracks necessarily. The slurry surfacing mixtures are fluid enough, more of a thin oatmeal consistency, if you will, that with a wide enough crack, we will be able to get some penetration of either the liquid, in some cases perhaps the aggregate, but we'll fill a crack. In some cases, we may bridge a crack with those applications. But by no means do we profess to be able to heal a cracking problem, as it may eventually be reflecting through whatever surface you put down. But once we do have a chance to fill these cracks, and I recommend to you that if you deem to have what you think is a cracking problem ahead of time, use your crack filling processes that you currently deploy. Okay, but once we get the road prepped properly, the mixes are going to be able to firmly adhere to the surface and give you that high friction weatherproof seal that you were looking for. The mineral aggregate that we use, as you can see in the picture here, is a relatively fine graded type of an aggregate. Now, inside of this number 10 rock dust, as this is what it's referred to over here, this number 10 rock dust can have different gradations to it. We will have 3 different types of gradations of stone, but they're all going to meet this fine appearance. You still put your hand into a pile of a type 3 aggregate, for instance, and it's not going to look much different than this, but we're going to have some larger aggregates that we're going to get into in a second to give you the friction coefficient that you're looking for. But at any rate, all the aggregates are going to be manufactured crushed stone of a high quality aggregates, depending on where you are in the country. It can be a granite, a slag, or a limestone, or even a chat material, but they've got to be a hard, non-polishing type of aggregate. And the aggregate should completely meet your project specifications, depending on what it is you're trying to achieve in terms of surface texture or skid numbers or what it is you're trying to achieve. We do have a gradation of stone to meet that need, but make sure that that stone through testing is going to be consistent throughout the process of the project. Emulsified asphalt that's used in the slurry surfacing mixes. They're all going to be cationic in nature, and these acronyms, if you will, you'll see that there's a C in front of all these emulsions that are going to be used in these particular treatments. And with regard to slurry seal in particular, we're going to use a cationic quick set emulsion. We may even be able to use a cationic slow set emulsion. And sometimes with the slurry seal application, we'll actually use this here LM designation, which would be latex modified. Sometimes we'll be able to use a latex modified slurry, which of course we're going to cover in just a little bit. Sometimes you put a latex in a slurry emulsion, but all the time with the microsurfacing, you're going to be using a polymer modified emulsion, either a CSS that's polymer modified or a CQS, a cationic quick set emulsion that's latex modified. In all these mixes, regardless of its slurry seal, polymer modified slurry seal, or microsurfacing, we're going to need to introduce a little bit of a mineral filler to the recipe. The mineral filler is going to serve a couple of different purposes where it can help improve our mix consistency. And just a small add of these mineral fillers is going to help adjust the breaking and curing time of a particular mix. We're typically going to recommend the use of either a Portland cement or a hydrated lime to achieve what it is that we want in that recipe. At times, you may even see a granular aluminum sulfate that's been specified. But we're talking about small quantities of materials here. Anywhere from half to no more than 2.5 or 3% by weight of your aggregate is going to be one of these mineral fillers. So it's a very, very small amount. If you can just put it in perspective, a dump truck load, we may use one of those 92-pound bags of Portland cement and load that size. So it's very, very small, but the chemical reaction is what we're looking for to help adjust the mix. Even though the emulsions that we use have a certain amount of water in them, a high percentage of water, we're going to have to add a little bit of additional clean and potable water to the slurry mixture itself. And that's going to be regulated by the moisture content of the aggregate that you're using. And this water adjustment can be made easily on the run by your operator on the paving equipment. And it's going to vary, especially in weeks like what we've had here in Central Virginia. 3.5 inches of rain on Monday night is going to saturate a stockpile to work on Tuesday morning. So we're not going to need near the amount of added water to the slurry mixture on Tuesday as we did on Monday prior to the rain. And that water is typically just obtained on site from a hydrant from your local agency. There may be cause for an additive to be used, but that's going to be used at the discretion of the operator and the crew on site, and it could be just an additive that's on board the paving equipment that can adjust the mix to be a little bit more workable, especially on very hot days when the surface temperatures will be accelerated. In this part of the world, it's not uncommon by the middle of the summer to see pavement temperatures of right near 140 degrees. So when we're just starting off with a startup joint, starting the paving of a project, if the pavement is that hot, you may need to add a little bit of additive to the mix, but it's just a one-time add, and it's not an emulsion load completely full of this additive. It's just an as-needed basis. So what we're talking about putting this stuff down as a homogeneous mix on the road and adhering to the road. What's a slurry paver piece of equipment look like? Well, it's a dump truck. It carries the aggregate and materials to the paving site. A slurry paver piece of application equipment is also a portable asphalt plant. It can also be considered an actual paver with a screed on it, where we have our own spreader box attachment to the back of our slurry paver truck. Although slurry surfacing systems do not require, for the most part, any rolling or compaction, depending on the way we set up that paving screed on the back of the slurry application equipment, we can adjust the, not necessarily compaction, but the texture of the final mat that we're going to use. It might be worth noting here that any compaction at all on a slurry seal or a microsurfacing job would be done with a pneumatic roller, and typically only in parking lot applications or potentially airfield pavements. Now, this application equipment comes in all different sizes, and what we're looking at here are what we'll call 2 truck mount application pieces of equipment. These machines will carry all of the necessary materials that we just went over, the stone, the emulsion, and the mineral filler, and any potable water. All those materials are carried on board. The smaller equipment like this is very well suited for, as the picture on the right will show you, in a neighborhood setting. There may be narrower streets, there could be cul-de-sacs, and certainly these smaller pieces of equipment are much more maneuverable on a project like that. And us as contractors would like to right-size the equipment for the type of project that we're on. Now, when we get onto a bigger piece of continuous run pavements, some longer pulls, we'll refer to this slurry surfacing application equipment as a continuous run machine. Now, the one difference I want to show you here is that on these truck mounts, when you're done paving and this truck is empty, this spreader box has to be detached and wait for the next unit to back up and attach to it and begin paving again, which creates a construction joint. But again, keep in mind that we've designed these projects to be done with this type of equipment because this is the equipment that's more suitable for that. Now, on a project like this, these continuous machines, they'll also carry their necessary materials on board, some of them, but they're continuously fed by what we'll refer to as either a nurse truck or a support unit. And these nurse trucks or support units are bringing equipment, or rather material, with them as well, and continuously feeding this machine. The machine theoretically will get its name being continuous, that there is a chance, depending on the availability of all of these nurse trucks that you have on the project, the proximity of the staging area that you're working from, the length of the project, theoretically this machine could run continuously and not have to ever detach his spreader box back here like the other guys did. And we'll be able to continuously run without creating a construction joint. That's the aim of the continuous type philosophy. All right, yeah. Application process. I thought I lost the slide there for a second. Regardless, now we just looked at those machines and said that they're carrying their onboard storage, and that they all the machines, whether it's a truck-mounted unit or a continuous run piece of equipment, all have their onboard storage. All of these materials are calibrated and distributed proportionately to this mixing chamber. Again, the back end of this machine is going to be continuously consistent between the truck mount unit or continuous machine. All of this apparatus is going to be about the same. So your materials are placed into the mixing chamber while the machine is paving from your right to your left. The materials are going to spend 15 to 40 seconds of mixing time here in this mixing chamber before it's deposited on the run into your spreader box. And as the machine is progressing along, usually at a pretty good walk pace, the material as it comes out the back of the spreader box is going to be a mixture that's brown in a homogeneous mix. The brown texture, the brown look you get is going to be because of that added water that you put into it, okay? And as you continue down the road, this material is going to be breaking, we'll call, or the evaporation of the moisture that's in there. And that break time can take anywhere from 1 to 2 minutes. And then 1 to 2 minutes down the road, you're going to start seeing the material turn from that brown milky color to a darker, more black surface that you're looking for as that water evaporates. Now with a slurry seal, that water getting out of the mix at this point is completely dependent on ambient conditions. That is going to be a completely evaporative method of extraction of the water from it. Now when we come to the microsurfacing, we're going to have what we'll call a chemical break. There are some chemicals in the emulsion in addition to the polymers in the microsurfacing emulsion that physically expel the water from that mix. And by the time we get back up in here and it's curing, it's not yet quite ready for traffic, but with your microsurfacing and most specifications that are in place now, you should be about traffic ready in about 1 hour's time with the microsurfacing, where the slurry seal being dependent on ambient conditions, it may take a couple hours or more before the slurry seal application is completely traffic ready. Okay, and I think, Jason, this is where our video is. If you can cue the video for us. Okay. And we're just kind of going to put this in motion, this last schematic that we had. Okay. And it can begin playing anytime. Yeah. I don't think we're getting it to activate. But, you know, what we're looking at here, okay, I just saw a slide jump. But here's your nurse truck or your support unit. He's bringing all the materials that he needs to the paver. Up here, you'll see where I get the arrow to work. Yep, it's not doing it. Apologize here. Here we go. Okay. The truck, as it's moving along, here's your aggregate up on top. Then we have on either side of this particular machine, as it's delivering materials to the paver, we have a saddle tank on either side of the equipment that's delivering the water and the emulsion. Here we go. To the paver. And technology is wonderful. But it's transferring the material back to the paver here. The liquids are being stored, you know, in saddle tanks on the paving equipment here on either side of the paver, or some tanks where the liquids are transported to. The stone is delivered into the front hopper here, and then conveyed up on a conveyor belt up into the machine just up here above where that top fellow is standing. So there is room up top for some aggregate to be stored. And that's another clue on why these machines are just referred to as a continuous run machine. When this truck happens to empty and all his materials are expended, he's going to have to pull away. Now he's pulling away, but number one, this spreader box back here stays intact. He stays connected to this paving machine because now on board this paving machine, we have enough materials stored to go, let's say a city block or so. So we're not wasting a whole lot of time in production and waiting for this next nurse truck to get back and hooked up to the paver. Okay. Jason, I think we can, we're moving. On the back of the machine here, there's an operator that's in charge of the mix. He's going to be monitoring consistently. And if the machine had moved past us by now, we'd have been looking at him. He is the chef. He's controlling the recipe, if you will. And on the back of this particular piece of equipment and on the back of a lot of the equipment out in the field today, there's actually computer generated data collection that he can refer to at any point during the day to let him know just what the output of the materials through this machine are. And for those of you listening in that might be project managers or inspectors, there's an opportunity for you to get that information as the day goes on to just get a good feel for what your application rates are in the course of the day. And it's a good check when the project is over with to reconcile quantities that have actually been used. Okay? Okay. Jason, you can go ahead and take that out of there. We better move on. Okay, good deal. Thank you. Now, we mentioned the aggregate that's used in the slurry surfacing applications. We do have, even though they all meet the same number 10 rock dust designation, there's going to be different types and sizes of aggregate. depending on the number 4 and number 8 sieve material that you have in the mix. For slurry seal, per the ISSA guidelines, one of the aggregates available is a type 1, or a very fine aggregate that you can see here is going to be about a 1/8 top size aggregate. So we're going to be putting a very, very thin application down with this type 1 aggregate. It's going to be applied at about 8 to 10 or 8 to 12 pounds per square yard. And being a very fine aggregate, it's going to require a bit more of residual asphalt content than some of the coarser gradations that we're going to look at in a minute. But the finer aggregates sometimes can be utilized in neighborhoods for just an absolute seal on the road that you want to have as a fine gradation and a smooth asphalt-like ride. Parking lot work and some low-volume airport applications as well. Now, we move on to a little bit coarser rock, and this type 2 aggregate was probably representative of the sample that was in that gentleman's hand in the one picture a few minutes ago. The type 2 aggregate is a little bit larger in size. We're talking about a 1/4 inch top size aggregate, so your application rates are going to approach a 1/4 inch with the type 2 aggregate. And note here that unlike the type 1 that's recommended for use only on the microsurfacing or slurry seal, we're now into the general gradation of stone that's applicable to both slurry seal and microsurfacing applications. As you can imagine, the application rates are going to be a little bit heavier, a little bit thicker application. Some of these application rates have recently been amended. I apologize, this is an older slide. But this type 2 or general aggregate size is typically going to be applied in the field between 14 and 18 pounds per square yard. And again, we'll go a little bit coarser on the aggregate side, so we're going to go a little bit lower on the residual asphalt content. This 5.5% low end of the residual asphalt content, we can reasonably go ahead and revise it upwards to about a 7.5%. On the low end to a 13.5% residual asphalt content on the high side. And keeping in mind that these are just guideline specifications, your actual specifications at home may actually tighten that range down a little bit to be more in the middle of the road there. But the type 2 aggregate is not coarse enough that you wouldn't get away with it on applying it to residential streets. Certainly some county roads and your normal airport applications are generally where the type 2 aggregate is placed. Now your type 3 aggregate, we're still in the fine aggregate categories. We're still in the number 10 rock dust. We've got some more number 4 aggregate in this type 3 gradation. It's going to have a 3/8 top size aggregate in it, so your application rate is going to be in the 3/8 of an inch range. The application rate, again, let's amend that a little bit to approximately 18 to 24 pounds per square yard with one application of slurry seal or microsurfacing. And again, the coarser aggregate, you can also expect to use a little bit less residual asphalt content. There's less surface area of the aggregate to be coated by the emulsion. So we're going to revise this to about 6.5 to 12% residual asphalt content for your type 3 aggregates that you can use on busier roads, 4-lane highways, interstate highways, some busy 2-lane roads, places where you want a little bit more of a heavier duty application and enhanced skid numbers. Just to put a graphic and a visual on it, your type 1 aggregate in the top left there is pretty fine in nature. The type 2 is more middle of the road. It's yet a little bit coarser, but not too aggressive. The type 3 aggregate is going to be your most aggressive application for a thicker application or a more aggressive skid number that you're looking for. All right, the slurry seal, your unpolymerized slurry seal is going to be described in the guideline A105 in the ISSA documents. It's a blend of crust aggregate or number 10 stone and asphalt emulsion, mixed and spread in a mobile operation. And we'll just say 1 stone thick. Okay, we're not trying to do any reprofiling here. Slurry seals aren't going to offer any structural value or be able to be placed more than that 1 rock thick. But even at that, if it's placed in the right road, you can expect and extend that serviceable life of the pavement by an additional 5 to 7 years. Now that we have options within the disciplines in the family and the slurry surfacing tools, your unpolymerized slurry seals are typically used on lower volume roads such as residential streets and secondary roads. It's not designed to be able to fill ruts or do any reprofiling of the pavement. Due to the higher residual asphalt contents in your normal slurry seal applications, it's not recommended to be placed in multiple lifts. However, with the slurry seals, as we see in a minute, it can be polymer modified. Slurry seals are thin and viscous comparatively in application, and we'll just have just an example here. The spreader box typically used on the back end of a slurry application truck is going to be a little bit, like a better term, flimsier, not flimsy, but certainly lighter construction. There may or may not be the presence of augers here in your spreader box to distribute material from side to side. And we'll see the difference in that in the microsurfacing in just a minute. And then over here, just a typical application site for a type 2 slurry seal, lower volume road, residential street. The microsurfacing is covered in ISSA guideline A143, and the microsurfacing is similar in a lot of ways to slurry seal with regard to site selection. Even though we're beefing this material up and we're able to use it on higher volume roadways, it's still a thin restorative treatment that's going to be used very effectively as a preventive maintenance treatment on higher volume roadways such as primary roads or interstate highways. Unlike the slurry, we do have the ability with the microsurfacing to correct some consolidation type rutting, but be careful to use that properly, and we're going to get into how you identify proper types of ruts that we can fix here in a little while. But I know you're familiar with in urban settings, shoving and rutting at intersections or bus stops typically are not good places for this microsurfacing to be used as a rut filling material. And by virtue of the chemistry in the emulsion that allows it to dry quicker than slurry seal, that's why we got the quicker turnaround on traffic with the microsurfacing, you can place the microsurfacing at night. You also have the ability with microsurfacing to place it in multiple lifts for extra durability and to correct some minor deficiencies or distresses in the pavement. I would be careful just for the sense of economics that realistically, if you get past a couple of layers of microsurfacing for the cost of putting a third or more lifts down, you're probably realistically in the category of being able to put a thin lift asphalt down for the same amount of money. So be careful of what kind of distresses that you're trying to address with the microsurfacing, and we'll talk about that in a little while. But yes, you can place this particular material in multiple lifts. And microsurfacing is always polymer modified. And due to the fact that you can address some minor distresses, you can go further down that pavement condition index, big red line that we looked at. You can potentially extend that distress down the curve just a little bit further than a regular slurry seal. Okay, now here I described the slurry seal spreading box a moment ago, and it was, again, a little less sturdy than your conventional microsurfacing spreader box here. We have a faster setting material that has the ability to be placed in thicker lifts. We have here, in this particular spreader box, some dual augers that are going to keep the material in suspension and distributed the full width of the pavement. And here is what I was going to point out on the paving train in motion. As they went by, I was going to point out this secondary strike-off on the microsurfacing box that can act as that roller that we're talking about. See, he's creating the surface texture and final matte look that he's after with that with the adjustment of that secondary strike-off on the back of the microsurfacing box. And obviously here we're into a little bit potentially busier roads, a little bit heavier application due to increased traffic can be placed on these busier roads. One other capability of a microsurfacing that we have that you do not have with either the slurry seal or the polymer modified slurry seal is the ability to place what we'll refer to as a scratch coat, or much the same as a wedge and level with your fine graded hot mix asphalts. But it's used only with microsurfacing that have minor irregularities in a strip of road that are narrower than the width of the spreader box. You may have some advanced oxidation where you might have lost the fines, certainly, and you've got some segregated pavement. That may be one coat of microsurfacing or one coat of slurry seal aren't going to fill in and level completely. So this scratch and level course can go a long way toward reestablishing a template to build your final ride surface on. Or on pavements that have longitudinal wheel path ruts of a ½ inch deep or less, we can correct that with the full width spreader box again here behind the microsurfacing machine. Okay, so that's an important point to make, that ruts a ½ inch deep or less can be effectively leveled and addressed with the scratch coat. Whereas when we get into rut filling, then we're going to need to do something a little bit different. When you have a wheel path rut, we still need to, while we're determining what's causing the rut, the pavement structure itself needs to be structurally sound, and the rut's not caused by any base failure or subgrade failure. If the ruts were caused by, the ruts need to be caused by mechanical compaction of the pavement, or what we'll call consolidation rutting. We'll see a graphic example of that in a moment. Ruts are flat and sharp, not showing dual wheel marks. We may have seen on interstate pavements in particular, tractor-trailer traffic and the indentations of wheel marks in wheel paths indicate some sort of plasticity in the surface mix that's not consolidation in nature and not something that a microsurfacing application should be able to fix. And we touched about the shoving at intersections. So any kind of that plastic deformation at intersections is certainly not a proper site for rut filling either. And if the ruts contain fatigue or alligator cracking, then there's usually a good indicator that there's something structural going on beneath that rut. So if we are going to go out and after we've done some forensics and determine what kind of rut problem we have, instead of that lane-wide spreader box that we looked at during the scratch coat and the full lane application technique with the application equipment, we're going to have a specially designed rut filling box. Now, this rut filling box, okay, we're going to be paving toward you with this particular box here, and the truck is backed up to it. Right here where we've got the arrow is where the microsurfacing mix is going to be deposited. We now got a different auger configuration here, because V-shaped auger configuration is going to channel the larger rock to the center of that rut where it's deepest and needs the most stability. And what we're going to recommend as well, and you see on the next slide, I believe, these spreader boxes here are equipped with steering wheels here, in this case here, but they're able to adjust the crown on that one lane or half lane wide spreader box. What we need to do is to slightly overcrown that rut as the machine is placing the material to allow for the compaction of traffic. And the traffic at this point is going to compact the rut-filling material and get us back to a typical cross-section of the road for the subsequent overlay. And I'm looking right here. I just caught my eye on the left-hand side here. Greg asked, have you done any microsurfacing on concrete pavements with tire stud caused rutting? Yes, you can place the microsurfacing, Greg, and we're going to talk about that in one of the last slides we talk about, actually. The pavements with tire studs causing the rutting, that was typical up in the northern climates, and yes, that is an application area that microsurfacing can fix. Okay, we'll just move here. Now we'll go on to show you again, that rut box we're going to use when the ruts are 1/2 an inch deep and deeper. Now we've established that the full width lane-wide spreader box will be addressing ruts less than 1/2 an inch, but when we get into a rut that's got some depth to it, and we're going to say 1/2 an inch and over, we'll use that 1/2 lane-wide spreader box. And for each inch of applied microsurfacing mix, for each inch of rut that we're trying to fix, we want to use those steering wheels, if you will, to overcrown the center of that rut by about 1/8 or 1/4 of an inch, just to compensate for return traffic compaction and leaving a good template for the final coat. Okay. Now we'll talk a little bit about the polymer modified slurry seal. It's obviously a modification of the unmodified slurry. It's not quite your microsurfacing. It's represented by the newly released guideline spec A115. We're using 100% crushed high-quality aggregate, just as we're doing with the microsurfacing. We're also using that aggregate has a higher sand equivalence value, just like the microsurfacing material does. It is a cationic quickset emulsion with up to 3% polymer additive by weight of the asphalt. We're using the same application equipment as we're using with the microsurfacing. The higher horsepower pug mill, the heavier spreader box with augers, because we're dealing with a material that's a little bit stiffer than your conventional slurry seal. And it also has the ability to be placed a little bit thicker than the 1 stone thickness that we propose for the slurry seal. Here we'll say that the polymer modified slurry can be placed approximately 1.5 stone thick, but you're not going to be able to do any rut filling with it. And it's designed to be used on moderate traffic, low to moderate traffic scenarios. Certainly residential streets, collector streets, highways, and some minor deformation. And the minor deformation is where this additional 1.5 stone thickness can be put to place. So, but keep in mind, it's still basically a slurry seal with just a little bit of enhancement to it. But we do have some other physical characteristics with this polymer modified slurry that are certainly worth consideration. So why did we develop a new spec guide for it? Well, in most parts of the country, a lot of parts of the country, a lot of slurry contractors have moved well past the A105 or the conventional slurry seal specification. Particularly out west and in the southwest, where you've got the higher ambient temperatures, certainly accelerated surface temperatures, they began utilizing polymer modified emulsions to correct some of the issues that they were having. And they're using higher quality aggregates for this. They've got the opportunity to take advantage of some of the equipment advances that have been in the market recently. An agency, when they're using the conventional slurry seal specifications would be getting a basic slurry seal when really what they wanted was something else, something performing a little bit better. There might have been some activity with placing slurry seals that they just weren't getting the performance out of a conventional slurry that they wanted, but they didn't necessarily need to or afford to go to the upgraded microsurfacing material. So there was room in here for us to develop a new spec guide and come up with a material that's going to be sort of a middle-of-the-road application. But there's still plenty of places that a slurry seal is very well put to work, so it's not yet time to retire any slurry seal specification by any stretch. And not every job needs the A143 or the microsurfacing materials. You might have too high a traffic volume. You might require heavier application rates. And at that point, then you really should stick with the microsurfacing. But by virtue of the fact that you are a little bit beefier with this polymer modified slurry, you can generally go a little bit higher up that preservation curve than the microsurfacing. You're going to be somewhere on that red line in the neighborhood of the slurry seal, but certainly with the ability of the polymer modified slurry seal, you're going to be able to address certain distresses that a conventional slurry won't be able to. And all these differences are spelled out in the A105, 143, and 115. The cost associated with these mixes, now of course that's going to vary greatly from place to place in the country where you're working. But we're finding in what field experiences that we've had with the polymer modified slurry seal, it may add 8 to 10 cents per square yard to your conventional slurry seal price. That's just in our part of the world here. And that's just simple reflection of the added material cost to polymerize the emulsion. But it's not significant in terms of investment, but significant in terms of return on investment, I think. So where do you use a polymer modified slurry seal? Anywhere you use a regular slurry, certainly, but you want to ensure a higher performance, such as getting increased durability. Reduced power steering scuffing is something that we in our part of the world have really noticed in the projects that we've been able to put the polymer modified slurry to work. Again, if we're working in neighborhoods and ambient temperatures are in the mid-90s, we have high humidity here, surface temperatures approaching 140 degrees, somebody backing out of a driveway and sitting still and turning their wheels to leave the neighborhood was leaving some very, very unsightly scuffing marks. What experiences we've had is we're not eliminating. I can't claim to eliminate the power steering burns, but significantly reduced, 75-80% reduction in the appearance of power steering marks. You can use them certainly as a preservation seal on streets and roadways up to and including rural interstates in some part of the country. I can go back into Virginia years and years ago when we didn't have access to microsurfacing, and slurry seal was the thin treatment of choice, and there were many, many miles of interstate pavements treated with slurry seals at the time. But now we have these different options. If you've got higher traffic volumes and night work is what needs to be done, then you're going to have to stick with the conventional microsurfacing. We don't have the chemistry involved in this polymer modified slurry seal to be able to be placed at night. And even though we said earlier that this polymer modified slurry can be applied 1.5 stone thick, a little bit thicker than a slurry seal, in areas where you've got higher traffic volumes, I would stay closer to the single stone thickness just to avoid any potential flushing of the pavement. And again, we've addressed the fact that the polymer modified slurries can correct, they do a little bit of minor corrective work on low volume streets and roadways. Just examples of where some of these materials have been placed. Neighborhoods, curb and gutter neighborhoods. You don't see a whole lot of driveways in that particular picture on the top left, but The polymer modification in a lot of neighborhood applications that we have been familiar with has significantly improved the performance and acceptance level of these polymer modified slurries. Connector routes through neighborhoods, and the center picture maybe a little bit heavier traffic on a secondary road in the county. All these slurry surfacing mixes, though, do have weather restrictions. You're dealing with emulsions, okay? Slurry surfacing mixes shouldn't be placed if pavement and air temperatures are below 50 degrees and falling. However, if you've got a warm day forecast, these mixes can be applied to surfaces that have temperatures or ambient temperatures that are above 45 degrees, surface and air temperatures above 45 degrees and rising is certainly a good opportunity to place these materials. My big thing with regard to temperature restrictions, there's a little bit of wiggle room there between the 45 and 50 application time, but be really mindful of the forecast. If you're expecting any freezing temperatures within 24 hours of application, we're going to have to delay placing slurry surfacing materials if this freezing temperature is going to happen in the next day. And then, we established that the slurry seal and the microsurfacing will be placed in similar situations based on pavement conditions. So a lot of the results, you're going to get a lot of the same benefit out of both of them. Placed in the right place, you're going to seal the surface and prevent further weathering of the surface texture, of the surface of the pavement. You're restoring surface textures. You're improving the safety of the ride. Regardless of its slurry seal or microsurfacing, you're going to provide a new durable wearing surface. Be careful again with that word filling cracks. You might be able to fill or bridge some cracks with the slurry or microsurfacing, but use your crack filling tools to do any real crack sealing that's necessary. And there are some distresses that each one of them are capable of fixing. And particular slurry seals, you can take care of some light raveling or some potential light flushing of pavements, whereas the microsurfacing lends you the ability to do a little bit of the leveling or scratch course to create a good template to build on. And certainly the rut filling capability is singular to the microsurfacing over the slurry seal application. The benefits of the slurry surfacing, be it slurry or polymer modified slurry or microsurfacing, sure, it's going to cost a lot less than plant mix asphalt. But please don't confuse the fact that these are thin maintenance treatments and not in any way designed to take the place of a plant mix overlay. You're not building any structural soundness into a road with these thin treatments, and you can't address a road that has structural deficiencies in it necessarily. But put in the right place in terms of dollars, it is going to be about a fourth to a third of the cost of your conventional asphalt applications. No milling is required prior to a slurry surfacing application. You don't lose any curb reveal in curb and gutter sections. You don't need to adjust any manholes or utility castings. And due to the fact that the process really goes pretty quickly, it leads to a lot less exposure for the equipment and the crew on the project. And in terms specifically with microsurfacing, the quick cure times reduce traffic delays and get traffic back to running normally. Applied right in your good mixes, it will take on a hot mix appearance ultimately. It has a high friction surface that retains skid numbers for the life of the surface. I just got a call recently from a pavement engineer in our part of the world looking at placing a microsurfacing on a road that was previously microsurfaced. The surface he's looking at was 7 or 8 years old at this time. And skid numbers were still showing skid coefficient in the low to mid-50s on an 8-year-old microsurfacing application. Okay. Just by design, these slurry surfacing mixes, yes, there's going to be minimal loose aggregate as compared to maybe a chip seal application. We're trying to build a safe skid-resistant surface here, so we're not embedding the aggregate 100% behind this paving equipment that we utilize. So there is a chance that there's going to be some surface shedding of some top-size aggregate. It's going to be a one-time raveling phenomena that's going to happen, and it's not going to be significant. If it is, we've got other mixed problems going on. But in a city block application of a Type 2 slurry seal, you are going to get a little bit of raveling, and it'll shed off into the curb and gutter, but you're going to pick up way less than a 5-gallon bucket full of raveling in a city block section of road with your typical initial raveling. So don't be alarmed. It's going to happen, but typical project will call for sweeping to happen within a couple of weeks anyway. Materials are all 100% recyclable, and they're going to extend the serviceable life of your pavement by 5 to 7 years. So what is the right road? Obviously, I can't beat this drum loud enough. It's a structurally sound pavement that's got to be addressed with these thin treatments. We've identified arbitrarily between 4 and 7 years old after hot mix is placed that some surface stresses may be setting in. That might be an opportune time to think about slurry seal or microsurfacing applications. If you have minor cracking, depending on the frequency and severity of the cracking, be sure to seal them before the microsurfacing or slurry material is replaced. Local failures are okay. Just because you've got some potholes or a utility cut on a piece of pavement, as long as they're isolated and identifiable, just fix your local failures and bring your pavement condition back to overall structurally sound, and you should have a reasonable candidate for these applications. You know, there are several considerations to take into play when you're deciding, number one, is this a right road? Number two, it is a right road, but do I put a slurry on it, or do I put a microsurfacing, or is it suitable for a polymer modified slurry seal? All right, now early on, just rule of thumb, we identified slurry seals as being placed on lower volume roads and microsurfacing to be placed on higher volume roads, and the polymer modified falling somewhere in between. So, okay, if you've got an interstate pavement, what's going to trigger your decision tree initially, okay? You're in an interstate pavement, high speed, high volume, we're probably going to lean toward the microsurfacing. Okay, what kind of condition is that surface in? What kind of skid numbers do you want to get? How coarse of an aggregate size do you want to consider? Okay, what's the traffic volume on these primary roads or secondary roads? What kind of skid coefficients do we want to build in there? Okay, what kind of cracking issues do you have? Are there other distresses? Are the surfaces raveling? Do you have some minor rut filling that's necessary? Okay, then you can start building your decision trees and your matrices by what sort of distresses you're identifying initially. If there's pavement rutting, where do we got to go with that? Right off the bat, if it's rutted, we have to consider microsurfacing. But then we have to determine the cause of the rutting, and we'll see some examples of how people have done that here in a minute. But simply just saying, okay, I got rutting here at this intersection, I'm just going to level it with microsurfacing and go on, is probably not going to be a satisfactory decision. Utility cuts, you know, have they sunk? You know, are they sound underneath? Did the utility company just not get compaction before they finish their cut and open the road to traffic? Check those out. The pavement that you're dealing with, is it slick? You know, what sort of surface was on it before? Did somehow the asphalt surface flush? Was it a surface treated road that with subsequent traffic in the heat of the summer or through winter operations, did we lose some surface aggregate? Vegetation, where's the grass coming from? Are you having some random cracks with a little bit of vegetation in them? The interface in the curb and gutter on a subdivision street, is that where you're getting some grass and weeds growing through? you're in the south, do you have some Bermuda grass encroaching into the shoulder and further into some of the pavements? Pavement markings, you might say, hey, we're looking at pavement conditions. What do we got pavement markings in here for? Well, we might have just a really great road to put a microsurfacing on. We might have a really good road that a slurry or a polymer modified slurry will do just what you want to do to buy you the time you need. But if we've got certain types of pavement markings on there, we may need to consider some additional activities to alleviate those pavement markings, and we'll talk about that. Potential stripping problems are caused typically by a drainage problem, either on the surface or subsurface drainage. We'll talk a little bit about that. But, what are the three main culprits of pavement deterioration? I've been taught that it's water, water, and water. So we need to somehow ensure where we are that we're getting the water away from it, or that it has not been a problem in the past. Okay, and I'm just looking down here, questions that I'm not going to take time to type in, but shedding or that initial graveling is significant at cul-de-sacs. What is the slurry seal mix design recommendation there? Good question. That is a typical application site where that minimal raveling does seem to be much more significant. If you think about it, you've got cars just going in circles in a cul-de-sac. There's no way that there's enough straight line running traffic to move that aggregate out of the way and get it toward the gutter pan or get it to the edge of pavement. And quite honestly, some of that shedding on a secondary road that's an open section road, there is not going to be any future need for sweeping because the aggregate's going to be lost on the edge of the shoulder anyway. Yes, it's going to be more significant in cul-de-sacs. It's just going to trap that rock as cars are going around in the circle. That's where, and again, where I can say from experience, the use of a polymer modified slurry with the addition of polymer modification in the emulsion. That's one virtue that we know we've got with chip retention when the added polymers are in there. So you should see a relatively significant reduction in raveling in cul-de-sacs with the polymer modified mix. Okay. Can you fix my road? They want you to wave a magic wand and fix all sort of ills. They got really specific and targeted their patching opportunities there on the far right-hand side. But then there's always the call that you get to say, okay, I've got my road list ready. These are the roads that we want to slurry seal this year. Someone hasn't done their homework, and somebody maybe in a position like I am hasn't done his due diligence in making sure that agencies understand just what the limitations and capabilities of slurry surfacing mixes are. But these are some actual candidates and pictures I've taken fairly recently on jobs that I was called out to confirm that, yes, these are roads that we want to put slurry seal on. Well, obviously they're not, and we're back to the drawing board and in one particular instance, trying to come up with some more suitable candidates. But you'd be surprised how many misunderstandings are out there about what the limitations of the slurry seal and microsurfacing applications are. But the distressors are way too far advanced in these particular roads for that. Whereas these agencies here, a little bit more experienced perhaps, a little bit more well-schooled on just where the limitations fall. The top left picture here, they had a localized failure that was cut and patched. They at one point had done some shoulder widening, but that's been determined to be structurally sound. Now they've got a good road here, and they've already designated to start slurry here. So that road was identified. No, it wasn't the perfect road to start with, but they did a little bit of surface prep and got that road back into shape. Here, the surface deteriorations were minor alligator cracking on the surface. They hadn't deteriorated the pavement at all. a simple skin patch with surface treatment or tar and gravel was all they needed here. Okay. Here we've got what otherwise looks like a relatively good shape secondary road in a residential setting. Got one little failure here. Might have been an old tree stump. It could be a soft spot, a sunken utility or something from days gone by, but a localized patch there and maybe a little bit of crack sealing here will bring the rest of this road into really good manageable shape for a typical slurry seal application in this case. And we don't want to stick too hard and cure to the 7-year limitation. I was talking to a group one time, and we threw that 4 to 7 year idea at them. And a guy raised his hand. He said, "I've got a 7-year-old road that I need to do something to, and I want to go take a ride with you when we get down here and see if this microsurfacing is going to work on it." Well, this was his 7-year-old road. I don't know what condition the mix was when it was placed. I don't know what time of year the mix was placed. I don't know what the underlying, I'm guessing that there may be some moisture underneath here. I'm seeing some deterioration and failures. But point here is just don't trust the data. Don't say, well, Chuck said go to that 7-year-old road and put slurry seal on it. Take your data and get in the truck and go take a look at it, review in the field for any distresses that are beyond a typical 5 to 7-year-old pavement. But it's just a good place to start in that time frame, but identify and verify what kind of surface conditions you really have before you do anything. Here's another example, okay? A road, I don't know how old this particular road was when it was designed for a slurry application. The agency had gone and done some localized failures. They did no other crack sealing or no other pothole patching. How they determined this was the only spot on this particular stretch of road that was bad enough that needed some address before the, in this case, microsurfacing was placed. But, by the time we get there to take a look at it, you got to wonder, what chance do we have for success on this microsurfacing for this particular project? So went ahead and did the work. I'm familiar with it. We went back, and 6 months later, this is what it looked like. I'm not going to say that another 8 or 10 months down the road that you didn't have some of that reflective cracking coming back through here. It likely did, and I know in time it will happen. But, this is an example of getting down that pavement condition curve, pushing the limits of what the capabilities of these slurry surfacing materials can do. And in some cases, was this quite to the reactive mode where we just got to do something to this road? It was borderline there. But you can see here that, as I'll always say, the worst that these slurry surfacing materials will do is buy you some time, even in what may be one of the worst case scenarios. Will buy you some time to get you over the hump, okay? Holy cow, I got 5 minutes left. I got to move. Cracks in the wheel paths, indication of base or sub-base issues. Cracks in the wheel path there is a bad indicator. That's probably not a good candidate. Here we have a section of road that instead of coring, they actually took out a slab of road, determined that with the intermediate or interface of the pavement here in between the mixes is steady. There's no deformation below the intermediate layer, so microsurfacing is determined to be a good fix there. It's always a good idea to check your rut filling activities to be sure that you are at least filling the rut flush. Here's a road that had some minor rutting in it. Ruts a 1/2 inch or less deep, was set up as a slurry seal job. And even though it was recommended that microsurfacing should be placed, slurry seal was attempted to be placed there, and the slurry seal ultimately flushed within about a 2 or 3 month period. So that same road was treated with a 1 coat of microsurfacing to get the skid numbers back and restore the rut level. Slick or flushed or bleeding surfaces. This particular pavement here, it wasn't raining, but we had the headlights just shining off a very, very flushed pavement. The county agency there wanted to know what could be done with the slurry surfacing material to potentially bring back some skid numbers for them. By modifying a type 3 slurry seal mixture, reducing the residual asphalt content down to the low end of the acceptable range. The repair was done in the early spring of the year, and it was a successful fix to a slick problem. But I'm not going to say that across the board these materials can be used to fix all slick pavement. Please consult your local contractor before attempting to do that. Vegetation removal, bad mistake here. Bad problem here is this is a road that's a month old after the slurry was placed. No attempt to do any grass kill. It was probably way too far gone anyway. Point was made earlier about cleaning grass out of cracks and just alleviating any grass or vegetation prior to the application of the materials. Tree trimming, well, one way or another, they're going to get trimmed. If you're paving through a canopy of trees here, keep in mind that these pieces of equipment have got to get to the edge of pavement, and you're going to have a truck that's at least the size of a tandem dump truck that's going to need to get up against curb face to fully place the microsurfacing here. And as you can see here on this slide over here, the truck going through ahead of the paving equipment shook loose some leaves, and they fell in front of the sputter box before they were able to get caught. So we need to be careful with that. Pavement markings like thermoplastic paint, tape markings, or even some latex paint with reflective glass media in them will be problematic for slurry applications on top. They just simply won't stick well. We're going to have to do some line eradication. Okay. Subsurface draining issues, obviously puddles or ditches that hold water. If you've got water that's seeping through the existing pavement, that's going to be a sign that there's some subsurface drainage going on. There's some water trying to get out. What's going to happen is that placing a slurry surfacing mix on that situation is going to trap the water under there. The pavement's already begun to strip anyway. But placing microsurfacing in that case will accelerate the stripping. And if you happen to see some delamination in an area that was wet or suspected to be stripping ahead of time, if you pick up a little piece of microsurfacing underneath of it and have larger rock like that showing through, microsurfacing has stuck to the road, but now it's taken up part of the road because it's starting to just crumble. If you were to core that section of the road, chances are the core wouldn't be able to stay together. Combining slurry treatments might be necessary if the roads have reached a typical point that a single preservation treatment won't fix it. You can tailor treat the combination of slurry surfacing mixes to fit the situation. And in this case here, we tried to fix a section of the road that was a little down the deterioration curve, but they wanted a smoother riding surface when they got done with the microsurfacing. So in this case, a type 3 mix was proposed for the first coat to fill in the surface voids, and a type 2 was used for a second coat to smooth it out and give it a nice quiet ride. For those of you to this point shy of trying microsurfacing on interstate pavements, this particular pavement used several combinations of ISSA related issues to fix this. A section of interstate road that carries about 200,000 cars a day, believe it or not. There was some crack sealing done here in the main line. One coat of microsurfacing placed. One coat of slurry seal placed for cost savings on the shoulder. And a fog seal was planned here in the rumble strip once the project was completed. So big combination of treatments here to fix a bunch of ills. crack sealing, microsurfacing, slurry seal, and fog seal combined for a successful project. And have you ever been shy about putting a slurry seal or even a cape seal in a nice neighborhood? Well, this golfing community had some roads that had deteriorated to the point where a regular slurry wasn't going to fix it for them. They did go in and do a chip seal application first, and then came behind the chip seal application with a finer graded slurry seal application to give them the smooth ride that they were looking for, and everybody was happy. Combination of crack sealing and slurry, certainly a combination of microsurfacing over a previous microsurfacing in this case is certainly a good tool. If the road's in good shape, why not just apply the same material? This job here was a rut fill job ahead of an 1.5 inch overlay of asphalt, a perpetual rutting problem that was not going to be addressed with microsurfacing. Ultimately, they just fixed the ruts with the microsurfacing and put a little bit of a structure into it with the hot mix. Plant mix overlay here, slurry seal on the shoulder, a little cost savings there. And here's a placement of the microsurfacing on top of a concrete pavement on an interstate that had shared lanes or dual purpose lanes in rush hour. They just wanted to delineate the travel lanes with the darker microsurfacing. This case here, there was a tack coat applied ahead of 2 coats of microsurfacing to be durable enough to handle the traffic there. Bottom line is choose the right road, the right application for the right road, use it at the right time, use properly maintained equipment, and use a well-trained crew. The results should be the same regardless of what type of section of road you decide to choose. And whether it's a multi-lane divided arterial, a simple subdivision street, some country farm to market roads, or upscale neighborhoods that you want to reduce scuffing in. It really is about using the proper treatment on the right road and getting away from that worst first treatment. Initialize a preventive maintenance program before the roads deteriorate so far. It's been proven that sticking to this worst first philosophy is not an economically feasible decision anymore. Preservation just simply saves roads and reduces costs. And now more than ever, with what we're faced with this pandemic situation and the resulting budget that we're going to be facing here in the next fiscal year, treating more lane miles with less money is what we're going to be tasked with. So I would challenge that now more than ever is the time to explore the need and the importance of a preventive maintenance application. Some helpful links here, and I think you can pull this material up later, but certainly the Slurry, www.slurry.org website for some information on some further web-based training, these guideline specs that we've gone over. The 2021 Slurry Systems Workshop, which is probably the most intense 4-day hands-on and field learning experience for anybody to get involved in. Check it out at www.slurry. The Federal Highways website, they've just done some revisions on their pavement preservation checklist series, and they are very valuable. Just easy enough to carry around with you anywhere you go. Some great information on this checklist series. The roadresource.org website, go to it, play around with it. Get in touch with us at ISSA. We can hook you up with a super user to help you maximize your experience on that roadresource.org website to help tailor make your own pavement preservation program. And there's plenty of interactivity that goes on with that roadresource.org. I highly recommend you check that out. And of course, the National Center for Pavement Preservation is a clearinghouse for all sorts of very, very valuable information. With that, I just want to say thanks, and please stay safe out there. You can get my contact information through ISSA. I'd be glad to. I'm sorry I went a little long, but we can certainly help you with anything I can. We're all here to help out. I see there's a question here about opinion on rolling or not rolling the first layer in a 2-layer microsurfacing application, particularly in parking lots. Yeah, I would utilize a rubber-tired roller in parking lot applications, whether it's slurry seal or microsurfacing. Okay. Looking over here. Okay, that was that. So the only last question I saw, I'm sorry, I was trying to get this thing going and answer questions as we went. Please forward them on. We'll be glad to answer individually. Allie, I think you had something you wanted to add here.
Yep, I just wanted to thank you again, Chuck, and FHWA and Jason Dietz for hosting this with us. The link